In the previous video, I demonstrated a way to make a plug-in replacement for this Altair Cassette Interface. We did this by using boards that were more readily available and less expensive than this hard-to-find and typically very expensive cassette interface. Now, if you recall, this cassette interface is actually a two-board set. You can see in the back there's a piggyback board. That is a modem. That's what actually generates the tones to and from tape. And then it feeds it to this front board, which is just a standard serial interface board made by MITS for the Altair. This is the 88SIO. Now, I did not use this serial board in the demonstration in the previous video because this is also rare and expensive. Instead, I went with a board made by another company called Solid State Music. It's their IO4 board. It's a bit more readily available, but even it's not flooding the market, let's say. However, that board is very configurable, and it was easy to make it look exactly like this board in terms of what software sees. Status register, data register in the exact same spot, status bits indicating transmit ready, receive ready, all identical, same polarity, etc. So truly a plug-in replacement. However, I've had a number of you ask if you could use a different serial interface board. You'd like to use this one right here. This is another board made by MITS. It's called the 88-2SIO. You can see it has two UARTs and two ports instead of just one, so that's why it's the 2SIO. This board came out about 9 months after the original SIO that we just looked at, and by far more units of this shipped with Altair product than any of the other serial boards. And so if you own an Altair from the early days, or if you've bought one in the last 10 or 20 years off of eBay, there's a good chance you've got this board right here as your console interface board. And since it's prevalent like that, you can understand why people would like to use it. Another good reason is because this first one is the console port expected by every software application in the Altair. However, this second port really has no assigned use, so it's basically free to use on cassette if you wanted to. Another reason getting this board working with cassette would be good is because there is a modern-day drop-in equivalent of it. This is the 88-2SIO JP. It also has two of the 6850 UARTs on it as well, just like the original. And this is just a drop-in replacement that software can't tell the difference, hardware can't tell the difference, 100% compatible with the original 2SIO. It also has a number of nice other features. But what it boils down to is that there's a number of ways that people could have a 2SIO or 2SIO JP, and that would be a handy way then to turn around and do a cassette interface with it. So, can this board be used to make a drop-in replacement for the cassette interface? Short answer, unfortunately, is no. The main reason is because the 6850 UARTs, the status register cannot be made to look like the status register that all the cassette software supports or expects. So what that means is it can't be a drop-in replacement. The only way you could use this is if you actually changed any and everything, the program you might want to use that had cassette support. And of course that sounds pretty daunting and sounds like a dead end. But in reality, it's not such a bad effort to do after all, and that's what we're going to talk about in the rest of this video. Before we dig into the software updates we're going to make, let's take a quick look at the hardware we're running this on. Down here at the end of the bus, I have the 2SIO board I'm going to use. This is one of the 2SIO JPs that we talked about previously. I have it strapped at the standard address expected by all Altair software. And when you have at the board at that address, this first serial port, which comes out on this board through this connector, is fairly commonly used as a console port. And so I have that connected through this cable over to this terminal that we'll be using in just a minute. With that first port addressed at the standard address, which is 20 and 21 octal, the second port on this board is then forced to be at 22 and 23 octal. And that comes through this port right here. So for all of our cassette routines that we need to patch, we'll be changing the addresses from the original cassette interface at 6 and 7 to this address of 22 and 23 octal to make that work. Now this second serial port is hooked to the back to a DB25. And just like in the previous video, we're going to loop that over to this other connector, which is hooked to the modem. And we have the Altair clone cassette interface board down here that we're using as the modem. Now, like we mentioned in that previous video, as of 2023, that board is still available if you want to purchase it, so we can get a modem for your project as well. And basically what it's doing is taking data to and from those audio connectors you see poking through the back and routing it to and from the RS-232 port. So that goes in and out through this port over here. Then in the back of the computer, I have these two looped to each other with a very short cable. And this essentially connects the 2SIO to the modem board. Now both of those are wired as DCE, so I have a little twist in the cable here to swap 2 and 3 so that I didn't have to modify those internal cables. All right, and also you can see the audio cables we're going to be using, plugging in the tape play in or the tape record out jacks, depending on whether we're loading or saving. All right, let's take a look at the software updates required to get this running. The first software package that made use of the cassette interface was 8K Basic. It was distributed on tape and could be loaded through the cassette, and then Basic itself added cload and csave commands to load and save programs to and from tape, and then also data arrays could be saved and loaded from tape. So that's what we're going to go ahead and load here first. And I'm going to do this as if I had no modern tools at my disposal, just like the person in the old days might have tried this. All right, so to boot 8K Basic, the first thing you would have done is entered a bootstrap loader using the switches on the front panel. And that bootstrap loader would have been provided for you in the Altair manual. And there's a number of those provided depending on the device you're loading through. Now, of course, there's not going to be one for loading through the second port on the 2SIO. Because like I said, no standard Altair software ever made use of that. However, there is a loader for the first port on the 2SIO that's provided, and that will be very close to what we need to do. And if you take a look, you can see it down here at the bottom. I've lost my pen I was going to point with. Let me grab it. All right, so this is the octal addresses and data for loading through a normal 2SIO, normal being the first port. And everywhere we see a 20, 20, 20, or 21, those are the port addresses being used of the first port. All we have to do is change those to 22 or 23 to get to the second port. Now you might want to do a little sanity check that the 20 and the 21s really are the ports. And you can see it here. This is loading 3 into the accumulator and doing an out to 20. So that's resetting the UART. This is loading 21 or 25 into the accumulator and outputting that to the control port on the UART, so that's correct. Here we're doing an in from 20 and doing a rotate right to check for the least significant bit to be set, so that is the status check. And then here we're inputting the actual character that was read. So yes, these 4 modifications to that bootstrap loader will get us up and running. All right, so that's pretty simple, and I've gone ahead and already entered that bootstrap loader with these modifications into the computer, so now we can try booting it. Go ahead and put the tape in. All right, now the way we're going to do this, we have the bootstrap loader modified, and it's going to be able to load off of tape. However, the bootstrap loader does not load all of BASIC. All it really loads is the first 200 bytes or so, which is a more advanced loader called the checksum loader. Now that checksum loader then goes to the front panel and looks at these 4 switches right here to determine what device to use for loading BASIC. And again, it's not going to have a device option for that second port on the 2SIO. So we are going to have to stop the program and patch it on the fly from the front panel. All right, so the closest one, again, is the 2SIO, just like the bootstrap loader. And a 0 or 0001 selects the 2SIO. So this will select 2SIO, but the first port at 20 and 21. And then when BASIC comes up and runs, it looks at these 4. So I'm going to put that to be the 2SIO as well. All right, so now what we're going to do is start this bootstrap loading, and then the second it gets to the checksum loader, I'm going to stop the tape so that we don't miss BASIC, which comes after the checksum loader. Then we'll stop this on the front panel and look at what it is we need to change. All right, so let me hit play on the tape. We'll hit run. So now the bootstrap loader is running. It's all down here in low memory. This slight glow is doing inputs from the actual port. That's the port address that it's reading to load the tape. See, we're at octal. Well, you can't tell because it's in the upper bits, but the second that address pattern changes, we'll know the bootstrap loader is running. Boom, it's running. Okay, so I just paused the tape. All right, so now we're paused, and this program is in the bootstrap loader, excuse me, the checksum loader, and it's just going to be in a tight loop, most likely, looking for data from the cassette. So we can stop it, and let's just single step and watch for this input light to come on, which tells us it's doing a fetch from probably the cassette. And, well, not the cassette. In this case, we had told it to do the 2SIO, right? So here it's doing an in from port 20, just like we expected. After that, this is an AND immediate with a 1, because that least significant bit is where it checks for data ready. This is a jump of 0 back to the top of that loop. All right, so that's the loop it's in. So to patch this, all we need to do, let's examine the next address. So here's the port address of 10. We want that to be, 20. We want that to be 22 instead. So I'll deposit that. So now we're going to read status from 22 instead. And then here is our AND immediate with 1. Here's the jump opcode, the jump address. And now, if it had found a character, this is going to do an in from the data register, which is 21. We want that to be 23. And at that point, we have this patch to load from the second port of the 2SIO instead of the first one. So now I can just hit run because we're in a safe spot to continue from here. And then release the tape to run. And now the checksum loader will be using ports 22 and 23 instead of 20 and 21, and will load the rest of BASIC for us. Now the reason we could stop this in the middle is because the Altair tapes had about 2 seconds of nulls between the end of the checksum loader and then the start of the BASIC data. And it's that 2-second gap that allowed me to stop this. And then I can make all these changes and start up again, and we haven't actually missed any part of the BASIC load that followed the checksum loader. Okay, this takes about 4 minutes. I'll come back after this is about done, and we'll take a look at it and see if it worked. All right, this should be getting close to finishing the load, and when it does, we'll see something pop up over on the screen on the right, the memory size prompt. We'll also see this address light pattern change when it switches from the checksum loader over to BASIC. There, just changed. Let me stop the tape. And if you come over here, we can see we have our memory size prompt. So at this point, AK BASIC is up and running. Hit return there, let it size memory. Terminal width, yes. All right, and we're up and running, loaded through our 2SIO cassette port. Now, BASIC does not have any idea about the 2SIO cassette port. It has the real cassette port in its logic, which is at addresses 6 and 7, and it has inverted polarity on the status bits. So now we're going to have to do pretty much what we did before over on the checksum loader. We're now going to have to do it here in order to make the cload and csave commands work. So how would we get that tight loop running where we can find those instructions? The easiest way is just to do some arbitrary cassette load command. At this point, it is in that loop looking for data from the real cassette. So we can do the same thing we did with the checksum loader, and once again find those instructions on the front panel. So if I stop it, do a single step until that input light comes on right here. All right, so here we're doing an input from IO address 6. That's the status port on the cassette. We're going to want to change that to be 22. Single step again. This is the AND immediate with 1. Happens to use the same bit possession for receive data as the 2SIO. Transmit bit is in a different spot. We'll see that later. So continue. Now this is doing a jump if not 0, back to the top of the loop. This is the opposite polarity of the 2SIO, which is going to be a jump 0. So we'll have to change this instruction as well. And then here's the 2 bytes of where to jump, and now we're back to the top of the loop. So let's do what we did before. So here is the reading from address 6. We want to change that to 2. We'll deposit that. So now we're going to do a status read from 22 instead of 6. Here's the AND immediate with 1. That's still correct. And now this is a jump if not 0. We want to change that to a jump of 0. And that is a 3. I have to look at my cheat sheet here. 312. So 312 is a jump if 0 instead of a jump if not 0. All right, and then it's to the 2 addresses. And now here is the input for the data from 7. We want that to be 23 instead of 7. So we'll deposit that. And so now we have our 23, and that should do it. Now the easiest way to get this started up again is just go back to 0. I did that with a reset. We do run, and we should be back at our OK prompt over here. All right, so Cload should now work. And I can go load a tape and we could prove it. Now, once you've done that once, you could write down those addresses, and then the next time BASIC comes up, just do a few pokes into memory. So I've made myself a little cheat sheet here of what those are. So if I do a peak of 4417, that is where I changed the input from IO address 6 to an input from IO address octal 22, which is decimal and 18. So what we could do in the future, I don't know if you can see these, is just when BASIC boots, just type these three poke statements, and that'll do the same thing we just did on the front panel. So in the future, you just do those 3 pokes and you're good to go. All right, now the save steps, if you even need to do a save, you could actually have that on tape and just load it, and I'll show you that in a minute. Anyway, so let's, we have nothing in here. Let's do a Cload of the primes program. Let me fast forward this. So we'll load the primes program. Since we patched Cload, it should just work through our cassette interface. All right, so that's there. Hit play, hit return, and let this load. This is a fairly short program. It has to get through the idle leader, and then it loads the program itself. All right, so that's loaded. You can see we have it in here, and we can run our primes program. So basically, we have gotten 8K Basic loaded through the 2SIO cassette, and we've now patched 8K Basic, and our Cload is working. Now, all this goes away when we turn it off, but it's just those 3 poke statements, and you'd get very good at doing the checksum loader there in the beginning. Now, what about the save? Well, the save actually requires 4 statements, 4 pokes, because we have to change the bit position that it tests for transmit ready. Instead of being up at the most significant bit, it's at bit 2, and so we have to change 1 extra instruction. So I put that on tape out here. Let me get to it. I put the csave commands as a program on tape, and so if you ever had to do a save, you could just load these first if you didn't really want to type them. I don't know that this is any quicker though. So let's clear memory, Cload. I call it S for save. All right, and now I'll load the program that includes the poke statements for enabling the save feature, the csave command, to work in BASIC. And once you've run those, then your currently loaded version of 8K Basic would work. All right, so here's the 4 poke statements. This puts IO address 22 octal. This is testing for bit 2. That's the jump of 0 instead of not 0. And then that is the IO address of 23 octal for running. All right, so at that point, now C saves would work. And I'm not going to bother you with that. Just trust me, it works. All right, so this is how somebody could have done it back in the day without any useful tools. Now, in the modern days, with disk drives and everything on our Altair, or even now our PCs, it's much easier to write software to make better things happen. So I've actually made completely patched, ready-to-go versions of all the bootstrap loaders. I've made patched versions of the tape so that the checksum loader supports loading through the second port on the 2SIO, and the BASIC on the tape already works. So basically nothing needs patching. You load these tapes, it just works. I've done it for all the software Altair ever made that use the cassette interface. That's this 8K Basic we're looking at. It's extended BASIC, and it's also the the software development environment for assembly language that Altair had called the MITS Programming System 2. And if I have time left in this video, I'll demonstrate that real quick. If not, I'll put some links to it or maybe do another video.